Dear students, in last class we have discussed an important concept of the electric charges and fields, that is electrostatic force, and we are going to learn more about this chapter. The topic is electric field. So when we consider a charge either positive or negative, there is a space around it in which if I place another charge called Q naught, this charge experiences force. If R is the separation between them, we can find the force between these two charges using Coulomb's inverse square law. So what is the force experienced by the charge Q naught which I have placed? What is the nature of the force? The nature of the force is repulsive, so it will be in this direction. And F is the magnitude. So what is the value of that force? F is equal to 1 by 4 pi epsilon naught, and I am going to consider that epsilon r to be equal to 1 because I am going to assume that these two charges are in free space, and then product of the charges Q naught by r square. So that is the force experienced by Q naught as well as the force experienced by plus Q. Now if I place this charge slightly away, R increases, force decreases. Now when this force becomes 0, so the force becomes 0 only at infinity. If I place this charge Q naught at infinity, then R becomes infinity, F becomes 0. And the space around any charge in which the other charges experience force, that space around it is called as region of electric field. It's called region of electric field. So this Q which I have taken, I'm going to call it as a source charge. Why source charge? Because it's a source of electric field. This Q is a source of electric field. And this Q naught that we have placed is called as the test charge. So Q is the source charge and Q naught is the test charge. Why it is called test charge? Because this charge is used to know the presence of the field. So moment this particular charge experiences force, we can say that there exists an electric field. Imagine if the force on this particular charge is 0, then we can say that in that particular region or at that particular point, there is no net electric field. So therefore, the purpose of introducing this test charge is to know the existence of the electric field. So what is an electric field? It's a space around a charge in which other charge experience force. That space is called electric field. And how to find the strength of the electric field? The strength of the electric field, which is denoted by E, is given by force per unit charge is called as the electric field. So how to measure electric field? It is a force experienced per unit charge is called electric field at that point. So E is equal to F when Q naught is equal to 1. Am I right? See, E is equal to F. E is equal to F when Q naught is equal to 1. 1 means it's a plus 1. So we can even define like this: electric field at a point is equal to the force experienced by unit positive charge placed at that point. Unity means 1 and positive charge, correct? E is equal to F when Q naught is 1. Okay, let's find the expression for electric field. So F by Q naught. What is the value of F? F is here 1 by 4 pi epsilon naught Q naught by R square divided by Q naught, correct? Divided by Q naught. And this Q naught will get cancelled, and there we get an expression for electric field which is E is equal to 1 by 4 pi epsilon naught Q by R square is the expression. Very important. So what are the factors on which electric field at a point depends? Electric field at a point, the point is this, depends on Q. What is Q? Source charge and not the test charge, correct? Because this is the electric field produced by which charge? Source. It's a source of electric field. Divided by what? R square. Where what is R? Distance of the point from this particular charge. So, what are the factors on which electric field depends? It depends on the strength of the source charge and the distance of the point from that particular charge. So, that is an important expression. So, we are going to use it while solving the numerical. Okay, that is one. Then the next question which they have asked in the examination is what is the SI unit of electric field? It is a one mark question. So, I can also use one more equation, E is equal to F by Q naught, correct? What is F? Force, which is measured in Newton. What is Q naught? It is a charge measured in Coulomb. So, Newton per Coulomb is the unit of SI unit of electric field. So, therefore, do remember two equations. One, electric field E is equal to 1 by 4 pi epsilon naught Q by R square, or E is equal to F by Q naught. From this, we can even calculate like this, F is equal to Q naught into E. That means, if you know the strength of the electric field E, and if you place a charge Q naught, then you can even calculate the force acting on it. If it is in vector form, then it will be like this. Vector F is equal to Q naught into vector E. So, remember, electric field is nothing but force per unit charge. Force is a vector. That is why electric field is also a vector quantity. So, that is for how to write this equation in vector form. Vector E is equal to 1 by 4 pi epsilon naught Q by R square into introduce a unit vector. So, that is the way we can find the electric field in, or we can write the expression for electric field in vector form. E vector 1 by 4 pi epsilon naught Q by R square into R cap. So, what is the expression for electric field? E is equal to 1 by 4 pi epsilon naught Q by R square, or electric field is also given by force per unit charge F by Q naught. From here, if you know electric field and if you place a charge Q naught at that particular point, then we can find the force using F is equal to Q naught into E. Now, since electric field is a vector quantity, it is very important that you should know the direction, the method of finding the direction, and that will be useful in solving the numerical. Okay. So, how to find the direction? So, let me consider two charges. One is source charge plus Q, the other source charge is minus Q. These are two different charges. Okay. At a distance r, what is the electric field? To find the electric field, always introduce a positive charge plus 1 coulomb, because electric field at a point is defined as the force experienced by unit positive charge placed at that point. Even if you do not place that plus 1 coulomb, still the electric field exists. Okay. Now, the purpose of writing is to find the direction of the electric field at that particular point. Before finding the direction, let us write the expression. What is the electric field? E is equal to 1 by 4 pi epsilon naught Q by R square is the expression for electric field. What is the direction? Look at this. This is a positive charge. This is also a positive charge. What is the nature of interaction? Repulsive. So, it will repel in this direction, and that is the direction of electric field. So, to find the direction of the electric field, introduce a unit positive charge and then see in which direction it experiences the force. That itself is the direction of electric field at that point. You take a negative source charge at a distance r. What is the expression for electric field? Same thing, E is equal to 1 by 4 pi epsilon naught Q by R square. How to find the direction? Introduce a unit positive charge. It has to be unit positive charge only. You cannot replace it by a negative charge. It has to be plus 1. Now, see the interaction. A negative charge attracts a positive charge towards it. So, this will be the direction of the electric field. Magnitude is same in both the cases. Whether it is a positive or negative, you have to consider the positive sign only. So, this is the expression for the electric field, magnitude of the electric field, and these are the direction. That means, due to positive charge, it is away from it, and due to negative charge, it is towards it. So, these are two important points which you have to remember, and very useful while solving the numerical. Okay. Now, what if there are many charges, system of charges, plus Q1, plus Q2, plus Q3 and so on. If there are many charges are there, okay, not one, many, then each charge produces its own electric field. Due to plus Q1 there is an electric field which is E1. Due to the second there exists another electric field E2. Due to third there exists one more electric field E3. And all the three fields, they overlap. Now this is called superposition of the fields, overlapping of the fields. So how to find the resultant electric field? The resultant electric field is always is equal to the vector sum of the electric fields due to individual charges. So this is the principle of superposition of electric field. So whenever many charges are there, find electric field due to each charge and then add them vectorially, not algebraically, but vectorially to find the resultant electric field. So now let's solve problems based on this concept. So very quickly let me give the equation that we have derived just now. One expression for electric field, E is equal to 1 by 4 pi epsilon naught Q by R square. Due to positive charge, the direction of it is away from it. Due to negative charge, the direction of the electric field is towards it. The SI unit is Newton per coulomb, and the force on a charge Q naught is given by F is equal to Q naught into E. So remember this much to solve numericals on this, and there are three numericals which they have asked in the examination. So now let's solve them one by one. So first numerical. So this question has appeared twice in the exam, and so this is the question that has appeared this year March exam. Okay, so let's go through that statement by statement and then we'll solve the numericals. Okay, right. So the first part of the statement, point charges QA plus 3 microcoulomb. I'm going to write somewhere here. Point A, this is A, okay, plus 3 microcoulomb. Plus 3 microcoulomb, and QB. So somewhere here we have another charge which is B, QB, which is minus 3 microcoulomb, okay, are located 20 centimeter apart. So this much. I will do the conversion from centimeter to meter, divide by 100. So 20 by 100, you will get 0.2 meter. They are located 20 centimeter apart in vacuum. So the space is empty here between A and B. There is no medium, it's free space, vacuum. Now what is the electric field at the midpoint O of the line joining AB? So A and B, and they have given midpoint O. So there is a midpoint O, the line joining the two charges. Okay, so we have to find the resultant. So we'll come back to that second option later. So now let's focus on this. So here I have to find the field. Now while finding the field here, how do you find the electric field? The formula is E is equal to 1 by 4 pi epsilon naught Q by R square is the formula used. So always write the formula before you solve a numerical, otherwise you are going to lose mark if you don't write the formula. Okay. Now what is Q? One of the charge, correct. What is R? Distance of the point from the charge. I want this distance. So this is 0.2. So this is half of it, 0.1 meter. So this is also 0.1 meter. Now at this point I have to find the resultant electric field. So to find that, introduce or write plus 1 coulomb. That will help you to write the direction of the electric field. Okay. Because even if you don't place plus 1 coulomb, there exists an electric field. It is just to write the proper direction of the electric field, we draw plus 1 coulomb. Okay. All right. So let's find the field at this point due to first charge. Then we'll find the field at the same point due to the second charge. And there will be two fields overlapping each other. Then we'll find the resultant of the two fields. Okay. Right. So I'm going to start with the E suffix A. that is field at this point due to A. So this is the formula, 1 by 4 pi epsilon naught. What is that constant? 9 into 10 to the power 9. First charge, 3 micro, 10 to the power minus 6 divided by 0.1 square. Okay, 0.1 is, what is 0.1 square? 0.1 square is 0.01, and that 0.01 I can write it as 10 to the power minus 2. Correct? Very easily I can write 10 to the power minus 2 as 0.02. Okay, right, for easy calculation. Now that's equal to, so 9 3s are here, 27 into, this goes to the numerator, it becomes 11. 11 minus 6 is 5, 10 to the power 5. What is the unit? Newton per coulomb. Okay. Now what is the direction of it? Check this here. This is a positive charge, positive is repelled in which direction? In this direction. So that's E suffix A. So we have to write always along OB. It's along OB. Okay. Let's find EB now. The field at the same point due to the other charge. So substitution is the same, which is 9 into 10 to the power 9 into 3 into 10 to the power minus 6. It's a negative charge, but while finding the electric field, correct, or while finding the force, we have to always substitute the magnitude of the charge. We don't consider the sign. Okay. So it's a 3 into 10 to the power minus 6 divided by same distance, 0.1 square, 0.01, which is 10 to the power minus 2. So you can see the substitution is the same. So answer has to be same, which is 27 into 10 to the power 5 Newton per coulomb. Now direction part, which is very important. This is a negative charge. Sorry, this is a negative charge. This is a positive charge. So what is the kind of force on it? Attractive. Attractive means these charges get attracted towards it, right? It will be like this. So there will be another vector which is acting along the same direction, which I'll write EB, which is along OB again. Along OB. Okay. So we have found two fields now. One is EA and EB. They are vectors. They act along the same direction. When two vectors act along the same direction, what is the resultant? The resultant is sum of the individual vectors. Correct? If you remember last year's formula, R is equal to root of P square plus Q square plus 2PQ cos theta, in which when theta is 0, that is when the vectors act along the same direction, R is given by P plus Q. So therefore, the resultant electric field, E is equal to E1 plus E2. Or EA plus EB. Okay. So what is EA? The value is 27 in 10 to the power 5 plus 27 in 10 to the power 5. So 10 to the power 5 is common, you will get 27 plus 27, correct, in 10 to the power 5, which is 54 into 10 to the power 5 Newton per coulomb. That is E. So this is the resultant electric field. Okay. So that is the answer to the first option. Now what about the answer to the next option? If a test charge of magnitude minus 1.5 nanocoulomb, okay, right, that is a test charge, which is normally symbol is a Q naught, right, for test charge, that's equal to minus 1.5 nanocoulomb is placed at that point, then what is the force on it? So if this Q naught is now placed here, what is the force? So we know the equation for the force, right? F is equal to Q naught into E. What is the value of Q naught? Here it is negative, okay, minus 1.5, which I'll write 3 by 2, okay, into 3 by 2 into nano 10 to the power minus 9 into, and then E electric field, which is 54 here, 54 into 54 in 10 to the power 5, 10 to the power 5, okay, yes. So minus, now 54 by 2 is a 27, and 27 3s are 81, 81 into 10 to the power minus 9 plus 4 is minus 4, okay, and we are calculating the force, so that will be in Newton. So therefore the value of the force is minus 81 into 10 to the power minus 4 Newton. Now minus indicates that the force is opposite to the electric field. See, electric field is in this direction, right? So we can write that is F is equal to 81 into 10 to the power minus 4 Newton along OA. Along OA is the answer. Okay. So this is how we can find the force. Why it is along OA? Because of the minus sign. Okay. Because force will be always in the direction of the electric field if Q naught is positive. Force will be opposite to the electric field when Q naught is negative. So when Q naught is negative, the force is opposite. What is the direction of the electric field? Electric field will be like this, along OB. So this will be along OB. So hope you understood an important question. It has appeared twice in the examination. Okay. So now let's try one more question, and see, once we solve numericals, understood. So you yourself try these numericals again without going through the video and then see how to solve. Only then you will be able to solve these particular problems. So this problem is there in the notes which I have provided, and that's what I am going to solve one after the other. Okay. All right. So let's try next one more question from the notes which I have provided. So question from the exam, which is from March 2017. Let's see how to solve this. 2 point charges, 3 nanocoulomb and minus 3 nanocoulomb, are placed at the two corners A and B of an equilateral triangle of side 0.1 meter. So first let me draw an equilateral triangle. Okay. So this is the equilateral triangle. So this is A and this is B, and the charges are placed. One is 3 nanocoulomb here and the other is minus 3 nanocoulomb here. Okay. Side 0.1 meter. So equilateral, so given 0.1 meter. 0.1 meter. Find the resultant electric field at C here. At C we have to find the resultant electric field. And to find that, always, as I told you, introduce a plus 1 coulomb. Okay. So what is the purpose of introducing a positive plus 1 coulomb? To write the direction of the electric field. Very easily we can write the direction. Okay. Right. So the first step is writing the equation. So don't forget that E is equal to 1 by 4 pi epsilon naught Q by R square. Okay. So what are the steps involved? Same thing. There are two charges. So find two fields and then find the resultant of both the fields. So let's start from here. I'm going to find the field at this point. Okay. So I have to draw all the vectors at this point. So first, field at this point due to this charge. So E A I will write, which is 1 by 4 pi epsilon naught, which is 9 into 10 to the power 9 into the charge is 3 nanocoulomb, 3 into 10 to the power minus 9 by R square, 0.1 square, 0.1 square, 0.01. You can write it as 10 to the power minus 2. Okay. So here this will get cancelled. We have 27 into 10 to the power 2. 27 into 10 to the power 2. What is the unit of it? Newton per coulomb. What is the direction? Positive, positive, repulsion. So it is get repelled in this direction. Okay. So that will be E suffix A. Okay. So I have written A, B, C. I will write this as a D. So that will be along CD. So we will find one more field at that point. Same point due to the other charge now. Okay. Constant 9 into 10 to the power 9. Same magnitude of the charge. Magnitude is same. Don't consider the sign. 3 nano. 3 into 10 to the power minus 9. By same distance 10 to the power minus 2. So this will get cancelled. 9 3s are 27 into 10 to the power plus 2 Newton per coulomb. That is the unit. Now what is the direction part? Direction is, it's a positive charge. This is a negative charge. Therefore this charge is attracted towards it like this. It will be like this. Okay. So that will be E suffix B. Fine. So I'm going to write this equation here because I need that space. Okay. E is equal to 1 by 4 pi epsilon naught Q by R square. Okay. So what is the direction? Direction will be along CB. Along CB. So now look at the diagram. There are two vectors are there. One vector is here. The other vector is here. What is the angle between them? Is it 60 degree? No. It is 120 degree. This is an equilateral triangle. So 60, 60, this is 60 degree. So remaining is 120 degree. Okay. So how to find the resultant? So we find that EA and EB are equal. See, their values are same. So how do you find the resultant? Theta is 120 degree. Theta is 120. And resultant E is equal to root of EA square plus EB square plus 2 EA EB, then cos theta. So this is of the format R is equal to root of P square plus Q square plus 2PQ cos theta. And keep in mind that EA is equal to EB. Okay, all right. So that's equal to root of. See, EA and EB are equal. So EA square plus EA square is a 2EA square plus 2 into EA into EB is, again they are equal, right? So I can write 2EA square cos theta is 120. Okay. So what is the cos 120? Cos 120 is minus half. Cos 120, let me write here, cos 120 degree. Okay. So that's equal to root of 2EA square plus 2EA square. Cos 120 is minus half, correct? So this 2 will get cancelled. Now what you get here is equal to root of 2EA square minus EA square is nothing but EA square. So what is the root of EA square? That is nothing but EA only. So what is the value of EA? EA is here. How much? 27 into 10 to the power 2. So therefore the resultant is 27 into 10 to the power 2 Newton per Coulomb. Okay. So in this, how to find that resultant? So one vector is here, other vector is here. You just construct a parallelogram like this, and the diagonal of that gives the resultant. Okay. So it will bisect the two. That means if this is 120 degree, then this will be 60 degrees. So which we can write 27 into 10 to the power 2 Newton per Coulomb, making 60 degree, okay, with EA or EB, making 60 degree with EA or EB. Okay. So this is how we can find the resultant of two vectors or resultant at a point C when two charges are given. Okay. So hope you have understood the steps in solving. Again, an important question, and you have to first find individual electric field, and then you have to find the resultant electric field. Okay, fine. So let's try one more question. Now this question again from the exam, and then we'll see how many charges are given here. Okay, then we'll find the resultant. Okay, right. So go through the statement of the question. 3 charges are given. So whatever the problem that we solved just now is with the 2 charges. Now 3 charges. 3 charges each equal to plus 4 nanocoulomb are placed at the 3 corners of a square of side 2 centimeter. Okay. So first let me draw a square here. So this is the square. This is A, this is B, and this is C, and this is a D. Okay. C and D in order. A, B, C, D. 3 charges each equal to plus 4 nanocoulomb, okay, are placed at the corners of square of side 2 centimeter. So side is 2 centimeter, 2 into 10 to the power minus 2 meter. I have done the conversion already. Okay. So that is given. So their values are 4 nanocoulomb. So at A 4 nanocoulomb, at B also 4 nanocoulomb, 4 nanocoulomb, at C also 4 nanocoulomb. find the electric field at the fourth corner. So fourth corner is this, D is the fourth corner here. This is the fourth corner. So first we have to find how many fields? 3 fields. One field at this point due to A, field at the same point due to B, and then the field at the same point due to C. That is how we have to calculate. So let's first make sure that we know all the distances. Do we know this distance? Yes, that is the side of the square. Do we know this distance? We don't know. That is the diagonal. Diagonal is always root 2 times the side of the square. So that's why it will be 2 root 2 into 10 to the power minus 2 meter. Okay. The diagonal is always root 2 times the side of the square. That is using the Pythagoras theorem. Okay. So that is how we can find the side. Okay. And we know this side already. Okay. So let's utilize this space now to find the electric field, resultant electric field at D. So first, writing the equation, E is equal to 1 by 4 pi epsilon dot Q by R square, which is very important. After that, let's find the field due to first charge, then we'll find the field due to the second charge, then we'll find the field due to the third charge. What is the first charge? 4 nanocoulomb. So constant, okay, 1 by 4 pi epsilon naught, which is 9 into 10 to the power 9 into the charge is 4 nano, 4 into 10 to the power minus 9 divided by distance, square of the distance. How much is this side? It's a 2 into 10 to the power minus 2 meter, correct? Square of it will give you 4 into 10 to the power minus 4, correct? 2 into 10 to the power minus 2 square, 4 into 10 to the power minus 4. Okay, that's equal to, this will get cancelled here, 4 will get cancelled, and what you get is 9 into 10 to the power plus 4 Newton per coulomb. Newton per coulomb. What is the direction of it? To find the direction, as I have told you earlier, introduce a plus 1 coulomb. Plus repulsion. So it will be repelled in this direction. So that will be E suffix A. So we have E, B, C, D. Normally we use E for electric field, I will write F. So it will be along DF. It will be along DF. Along DF. Let's find EB, which is here. Field at this point due to the second charge. Constant is 9 into 10 to the power 9. The charge is 4 nano, 4 into 10 to the power minus 9 divided by, now see the distance. The distance is this 2 root 2 10 to the power minus 2. Square of it, how much you will get? 4 into, that is 2 square, then root 2 square is nothing but 2 only, correct? Into 2 into square of 10 to the power minus 2 the whole square, 10 to the power minus 4. Okay, that's equal to, this power will get cancelled, 4 will get cancelled, and 9 by 2 is 4.5. 4.5 into 10 to the power plus 4 Newton per coulomb. Okay, for the direction of it, it's a positive charge, positive, repelled, so it will be along this direction. Okay, are you able to see that? Okay, so along, I'll write one more variable, that's a G, so that will be along DG, along DG. Okay, next again we'll find the field at the same point due to the other charge, which is 9 into 10 to the power 9. Charge is 4 into 10 to the power minus 9 by, distance is this, 2 into 10 to the power minus 2. Square of it, 4 into 10 to the power minus 4. 4 will get cancelled, this will get cancelled, so we'll get 9 into 10 to the power plus 4 Newton per coulomb. Now what is the direction of the field at that point? So this is a positive charge here. Positive, repulsion, it will be in this direction. So GH I will write along DH. Okay. So that will be along DH. So are you following how to solve the numericals? If there are 4 charges, find 4 fields. 3 charges, find 3 fields. 2 charges, find 2 fields, and then find the result. Okay. Now we have to find the resultant of these 3 vectors. The vector is something like this now. Okay. This one vector is here, the one vector is here, the other vector is here. So that is at D. So this is E suffix A, this is E suffix B, and this is E suffix C. See, the angle between EA and EC is 90 degree. EA and EC is 90 degree. So, let us first find the resultant of this. Okay. So, we are going to find EA and EC. So, what is the resultant of that? I will write it as E dash. Okay. So, when the angle between them is 90 degree, the resultant is root of EA square plus EC square. Okay. EA square plus EC square. Why? Because angle between them is 90 degree, the resultant is given by root of P square plus Q square. Okay. Right. So, but EA and EC are equal. Can you see that here? EA and EC are equal. So, I will write resultant of EA and EC. Okay. So, when they are equal, you can write like this, root of 2 EA square, correct, because EA and EC are equal, right. So, root of 2 EA square. So, that is root, that is a root 2 into, what is the root of EA square? It is EA only, EA, alright. What is the root to 1.414 into, so what is the value of EA? EA is nothing but, here it is 9 into 10 to the power 4, 9 into 10 to the power 4. So, that is E dash is equal to multiply. So, here we have 9 4s are 36, 3, 9 3 12, 1, 9 4s are 36, 37, 3 again, and 9 1s are 9 plus 3, 12. So, we will get 12.726, okay, into 10 to the power 4 Newton per Coulomb. So, this is the resultant of only these two. There is one more vector which we have to include, okay, right. Now, where do we get the resultant of EA and EC? Resultant of EA and EC will be along this direction, okay, that is along DG. So, here let me write, this is EC and this is EB, okay. So, that will be along DG, correct, because these are identical, correct. So, when you find the resultant of this and this, it will bisect, it will go along this direction. Now, along that there is already one more vector which is EB. So, now we get like this, that resultant of these two will be along this direction, which is E dash. Now, two vectors are along the same direction. When two, so here we have 12 plus 4 which is 16, 16.7 plus 5 is 17.526, okay, into 10 to the power 4 Newton per Coulomb, and that will be along DG, along this one only, okay, along this direction. So, it's a slightly time consuming, understood, right, but definitely not a difficult problem to solve, okay. So, hope you have understood the three problems which has appeared in the examination and how to find the resultant electric field. So, solve these, practice this problem, it will be, you will definitely find easier. So, go through this video again and again and then see how these numericals are solved, okay, right. So, I am going to continue with more topics in the next session. Thank you.